What's up, guys? This is Jakob. I'm content AI manager and I'm helping entrepreneurs around the world with their content strategy using AI technology for creating content for your business. That's basically what I'm doing. Welcome to a new episode of the Content AI Show. I'm the host of the show where I speak with experts around the world within the AI space. And today I'm going to speak with David Banik. He's the founder and the CEO of Nexus, which is a generative AI company, and also of Niftyverse, a mobile NFT platform. So very interested in speaking about two different worlds, so the AI space and also the Web3 space. So welcome to the show, David.
Hi, nice to be here.
Yeah, I really appreciate your time. Thank you for being here. So for all the people out there, can you maybe introduce yourself? So who is David and why are you doing the things that you're doing?
Yeah, I'm David Banik, and I'm the founder of Niftyverse and Nexus. And so I like the future, and I like to contribute to the development of humanity. So basically what I do now is I'm just trying to start some companies that I would like to make very successful. So like my dreams with uh, taking Nexus further, which is the generative AI company. We have a goal to make like uh, like a generative engine, which is basically like a search engine, but it's synthetic. So the results that you type in some text, and then the results that you get aren't going to be like real. They're going to be like AI generated results. And the idea behind it is that like you can get any type of output. So like you can get images or texts or videos. So right now we're starting with like images and text, and over the years we hope to develop into like a full-grown like generative engine, which is like just as useful and diverse as like, for example, like Google, but it's synthetic. So it's everything is generated by AI. Yeah, and so that's like the vision, and that's like what uh, like I as a person like hope to achieve. And like a little bit more about me personally, like I'm like a yeah, like a futurist, inventor, musician, artist. So I like creativity, and I like the future, and I like technology and science. So yeah, like I work in the space of basically um, like futuristic things. Like I also like mathematics, so I think about the future like very precisely, like mathematically. And yeah, so like that's kind of who I am. Like I also like I'm working on like understanding like the future in like a more like precise mathematical way. So uh like not only do I work towards making like the future happen more quickly, like with the technology and like with Nexus, for example. um yeah, I also like to study like the future, and in like uh I have like my own idea of like what's going to happen in the future. And if I make enough money one day, I might be able to prove some things about what might actually happen in the future with regards to like the whole universe and like stuff like that. Like universe turning into computronium. Like people have been talking about it, but I think like there might be a theory behind it, like a mathematical theory, which can actually generate some evidence if you have a strong enough supercomputer to find a piece of evidence. But yeah, like that's kind of like who I am. So that's that's kind of what I'm interested in. Yeah.
Yeah, so already many interesting topics. So one thing was also that I saw in your LinkedIn profile is you're the inventor of drone theory, the theory of
Yeah.
the system at the maximum of evolution. Okay, I mean,
Yeah.
what is this? Can you explain this?
So that's like a theory about um, like systems that basically it's you have any like Turing complete system or computationally complete system. It's basically a system that can have a computer that can run any algorithm. So our universe is a Turing complete system because like right now we're talking out through computers and those computers can like execute any algorithm, any program you run on them. So these types of systems, like if you have a large enough space time, so if they're large enough and if they run for long enough, then eventually uh, you converge to like a maximum of evolution, which is like basically like a universal computer. So any system that can support a computer can basically evolve into a computer. Like it will eventually evolve into a computer, like just through evolution. So our universe can contain computers, as is evidenced by like what we're using. And so like the hypothesis is that eventually whole universe will turn into a computer since it can contain a computer. Uh, so if you think about it, like right now we're like 13 billion years into the age of the universe, and um, we've just created computers like 100 years ago, and it's exponentially increasing. So eventually, you should expect that like there's other civilizations across the universe, and they can create like the same technology, and so it's kind of happens randomly, like where it occurs, but then eventually the whole like universe will like through these individual civilizations like working towards creating this like future. You eventually have the universe turn into like this maximally evolved state, and it can't evolve further because there's like a maximum to evolution. And so this system is like really interesting. It has like a lot of rich structure to it, and also the evolution that leads up to it is like also part of the theory. And so it's kind of like uh, you have a system, you have the maximum of evolution, you have the structure of that maximum, and then you have everything that leads up to it. And that's kind of like the whole like domain of like the theory. But the most important part is that maximum and the structure of that maximum. So I mean, arguably, I would say like if I could like write it down mathematically and precisely, um, there might be
I
like
couldn't understand it.
yeah, like I don't know the mathematics like right now, but I hope to eventually hire some people who can might help me to develop the mathematics behind this because like the goal of evolution is to get to that point. So it would be like understanding the goal and how to get there in the most efficient way. And I think it would be like potentially like the most important theory like ever. You know, like you have general relativity, you have quantum mechanics. Like those are quantum mechanics is probably like the best theory ever, right? Um, but like the point of evolution is to get to a certain like point in evolution, right? So uh, yeah, like it's like if we understood that maximum and how to get there in the most efficient way, it would be like the most important thing for us because that's what we're trying to do. That's like what civilization is doing right now. We're evolving. So like it's kind of like instead of doing things randomly and kind of uh, having a blurry image of what might happen in the future, it would be like exactly showing what's going to happen in the future and exactly like what the result of the evolution in the universe is. And like right now, we have like a very incomplete vision of the future because like the standard view of like the evolution of the universe has nothing to do with intelligence. Like you go 100 billion years into the future, and what's our prediction? Like all the stars basically start running out of fuel in like 100 billion years, and then like uh, like various other events can start happening like in between, like maybe 250 billion years, like galaxies start going like dark or something. But there's like lots of different things that we have predicted for the future of the universe, and all those predictions are basically practically invalidated if you have a completely different structure. Like if you turn all the stars into like machines that can be much more stable, like they can exist for trillions of years or longer, then like the idea that all these stars will like run out of fuel in 100 billion years, that might be completely incorrect if we turn all the stars into machines and then use their like energy for doing like simulations and maintaining the system and stuff like that. So yeah, it's like really important to understand this kind of theory, and I really want to eventually, like in my lifetime, hopefully develop the whole idea behind it, and so we can understand like the maximum of evolution, which would be like really interesting. It's like like all these different types of machines. Like I call it Tron because it's based off of the idea of computronium. So you have that word Tron inside of computronium, and so computronium is basically like a specific type of like what I call tronium, which is like like the generalization of what computronium is, just by saying like tronium is a generalization of computronium, and then you can have different prefixes which would specify like the specific function. So you have like computronium, and you have like mine tronium, transport tronium, different types of troniums, which would be like maximally efficient systems for achieving very specific operations. And then all this together would be like Tron. And so the point of it is basically to run certain like algorithms and computations. So you want to perform certain computations uh, like simulating mines. So like the whole point of it is basically just to make like as many beings, and like at least I think it would be to make as many beings and as happy as possible. So like you trying to maximize the happiness uh, of like the life that's contained in the universe. So you want to have the maximum lifespan and a maximum quality of life, and that's kind of like what like the whole universe will like the function of what it's gonna be doing. And so there's like different ways you can see that. Is one way is like, okay, so that's it's trying to maximize happiness, but what does that mean? It means it's trying to maximize computations, because if you want to have the most amount of happiness and the most amount of life, you have to simulate that, which requires, so the more simulations you can do, the more life you can have. So the more computations you want. So you want to maximize the computations, and that's what computronium is. And there's different types of like troniums that take care of computronium. Like there might be like a repair tronium, which is like you have like a ball of like computronium, like a rich structure to it, like it has maybe like a shell, or maybe it doesn't have a shell, because like if it's controlled like the whole universe, then like why would you need a shell to protect yourself? Because you already control everything outside of it, so it might not be necessary to have a shell. But like you have like different types of computronium on the outside. You have to the inside, you have, because you have a variable like strength of pressure in this ball. So different types of machines, basically different like lots of structure. Like you have, and it evolves, like it doesn't just like suddenly appear. Like the way it evolves too, it's like these mine troniums are like taking apart planets and asteroids, and they're disassembled in different ways based on the structure. Asteroids get disassembled in a different way than planets get disassembled a different way than stars. But that's just the transition phase. But yeah, like it's really interesting stuff. And like maybe the whole universe has already been transformed into like the maximally evolved state, and maybe we're already in like computronium and being simulated. That's what I believe. I believe it's most probable, like given like a universe of computronium, and given the previous like state of the universe, like how much life can be supported in a non-computronium universe versus a computronium universe. It's like so much more simulations can exist. So yeah,
Awesome.
I believe we're in a Computronian universe, which I like contract to Tronverse. It's like easier to say because it's just yeah, stuff like that.
It's amazing that you can just speak around 10 minutes about a theory. That's
Yeah,
awesome.
I
I
could speak
mean,
for hours. There's so much I can
yeah,
say about it.
yeah, I can really feel this that that you have so much to tell about this theory. That's great. So maybe let us focus on AI. So you mentioned several times generative AI.
Yes.
Can you explain what is the difference between AI and generative AI?
So generative AI is a subset of AI, and it deals with the creation of digital files. So yeah, digital
Okay.
files can have a lot of different structures. Basically, it's like a data structure. Like you can have uh, a row, just like an endless
Mhm.
row, and that represents text, one dimensional. Uh, so the files can have any kind of dimension. Uh, Text is a one-dimensional string. Uh, Images are like two-dimensional sets of numbers. Same thing for like audio. Audio is like a waveform, and so you can represent that as like a two-dimensional set of numbers. Maybe a little bit different structure for that.
Mhm.
Then you have like video, which is like a three-dimensional data structure. All these different types of data structures, and generative AI is it's itself is a type of the neural network is a type of data structure too. Data structure that generates data structures. You know, um, so what kind of data structure is it? It's basically it's just a one-dimensional like in terms of like the algorithm, the code. It's a string. Um, but yeah, like the generative AI, it the way it works is it just the neural network will uh, it'll generate like the file um, from like it's like has like a latent space, and it'll learn like concepts from data, and that data space will be like it'll gain more information, and when you ask it to generate something, it'll just go to like that latent space and generate something from that latent space, which is learned, like a general concept of like what it's learning. Um, and yeah, so like it's and then you can have like inputs to control the output. So like what we're dealing with is text input, but there can be other types of input. Like you can have audio input that turns into text. Um, so yeah, like the newest image generation models like DALI 2 and Imagen from Google. DALI 2 is from OpenAI. Those like text to image models, like yeah, you give them a form of text, then the generative AI creates a image based on that text, and yeah, so that's what like we are like having in our system. So yeah, like generative AI is like it's extremely useful because you can think of everything uh, in the world as like a file. Like if we were to represent the world with like a simulated version of the world, then every object in that simulation would be some kind of file. Like it would have an image on the wall, it would be like an image file. If you have a rock outside, it's like a 3D file. So yeah, like all these different types of files, and basically you can construct anything in the real world from a file. So if you have some machine to construct something in the real world, you just have to have a file for it, and then you can build it. Um, so in the digital world, like if you're in like a metaverse or something, uh, the generative AI can basically create anything in the metaverse. But we're not at that stage yet. But given 10 years, generative AI will be able to create absolutely anything. So uh, the most exciting things are like simulations. So you like maybe even farther in the future, the the generative AI that can generate simulations would have even more use because you'll have like a full immersion, like put some nanobots in your brain and they connect to every neuron and give you a full immersion experience. Um, but right now, we're just like in 10 years from now, the generative AI will be able to generate like simulations, like games, whatever you want to play, like in 3D, like interact with everything. So you might have like VR glasses and uh, some kind of like haptic gloves or a full body suit. And then you can just be in a virtual world and you say, I want to see a universe which has like any kind of superpower, and it looks like anime. So you're like in an anime universe with any kind of superpower, and then you just go there and you live in that kind of universe. And uh, that's like the entertainment side. So generative AI kind of a lot of people might think of it as like entertainment, but a lot of different applications also to like medicine and like generating uh, like like medicines and like we can generate like the the structure of like a machine or something like that, like a car, and and it'll do that in like the optimum way. And yeah, like there. So like with regards to technology, like generative AI would have like a lot of optimizations. So it would be like generating the optimal result, um, which is a little bit different kind of AI because you have to deal with optimizations. So that's like the more uh, like a technology like a useful side. But then the entertainment side, you just have like generating media. So um, yeah, like in the
Content.
future, yeah, like we like with the generative engine, you can just generate anything and like generate a video, watch it. You know, that's like my vision of the future. And like I have like if we make it like really successful, then like you can even take it like from virtual to physical, and there's just so much possibilities what to do once you can create like anything, and you have the resources to do that. Then uh, the world becomes really fun.
And what exactly are you doing on the Nexus AI? So, I mean, this you mentioned generative AI. So, what is your focus, or are there different niches that you deal with?
Well, right now, what we're doing is integrating models. Like a lot of the big tech companies, they create amazing models, but then they're not like open sourced. So what we do is we wait for a copy to be made, and it's usually pretty much always made by Lucid Brains, which is like shout out to Lucid Brains, they're amazing. But yeah, like we take it from their GitHub and like integrate it into the website. So that's how we're doing right now, because we're like very very small scale. Like we like don't have the resources to develop our own neural network, which is cutting edge. Like in reality, like if you want to make a cutting edge neural network, you have to be Google or OpenAI or something like that. You have to be like the top tech company if you want to make a cutting edge AI. So it's pretty much no point to doing that. So pretty much any AI company that's like uh, doing something that's competing with like this kind of models that are created by these big tech companies, they pretty much all have to like take something from like a copy of what they made. But yeah, like what we're doing is we're just taking like these neural networks from GitHub, and then we're applying them to like our website in like a user-friendly way. So it's like the most efficient way to get access to all of these neural networks. It's like just type and you get your results. So, um, and it's gonna be like free, right? So it's like when you use a search engine, it's free, and search engines have completely transformed the way people like live their lives. They get information like about anything, uh, pretty much just by asking the search engines or like asking your phone, and that has like radically influenced like civilization and our lives. And uh, so that's kind of like what I believe the generative engine can do. Um, so that's like we're making uh, like the same structure as a search engine for generative AI, so that people can have uh, like the most effective uh, like tool for creating any kind of content or entertainment or specific things that they need. Yeah, that's about it. Like, could be more detail.
Yeah. Okay, got it. And I mean, what was the main motivation that you started the Nexus AI? What
Right.
was that turning point for you?
So I just saw like um, a vision of the future in which people can create anything that they want um, from like technology. Like they just go on their computer and then they create anything they want. And just I was like, okay, so that's basically like the same thing. Like imagine if like Google just instead of being real was synthetic, and imagine if in the future there's something just like Google, but it's in a different like dimension, a different application. It's not creating or it's not finding things, but it's creating things. But it's basically the same exact uh, like external like structure. Like the way that you interact with it, it looks like to the user, it's like the same exact thing, but it's creating. It's like you in a way, like you can have like this with like the Turing test, like where you have a machine and you're trying to tell whether it's alive or not. And in the same way, you can do the same thing with your generative engine. Like you wouldn't know, you wouldn't
Yeah.
know if it was real or not. Like yeah.
Um, I'm sorry. Can we make a small small break?
Oh yeah.
My son is crying. Sorry,
Okay.
sorry for that one.